All right, thank you very much. So, welcome everybody to the presentation of our paper, Cascading Spy Sheets, where we exploit the complexity of modern CSS for email and browser fingerprinting. So, my name is Leon, and we are from CISPA. So, what I will show you today is, for example, a primitive to build obfuscated phishing emails. So the idea here is that you have a phishing email that looks like a regular phishing email to your target audience, but obfuscates the actual purpose in front of, for example, to someone who's tasked with detecting such phishing emails. And the primitive all of this is built on is browser fingerprinting. So first, let's get into some background on browser fingerprinting. And what this usually involves is you have a server that wants to fingerprint the user. And what you end up doing is the server sends some script to the client executes that in his execution engine, usually JavaScript, and then you return the fingerprint to the tracking party. And this fingerprint is then used for the purpose of identification. So what you usually want to do with browser fingerprinting is you want to re-identify users across different sessions. And the thing here is that current techniques largely rely on JavaScript. But, of course, there are also contexts where you do not have JavaScript. So there's, for example, the prominent Tor browser, which does not allow the execution of JavaScript. There is the NoScript plugin, which does that in a Tor browser, which can also be installed outside of the Tor browser. And you also have email clients where you can, for example, render HTML emails. And thus, the natural question is, can we also fingerprint here in these contexts where we do not have access to JavaScript? So let's take a look at the most interesting remaining technology that we have on the web, on the client side, and this is CSS. So CSS cascading style sheets look like this. So we have this big style thing on the left, and if we walk through this, it's actually quite simple what's going on here. So on the one hand, we have properties where we assign how the look and feel of an element should be. So we can, for example, set the color of an element to red, we can change its width, and we can also change a variety of other properties. Then we also have some more interesting things like functions, where we can do a lot of these things dynamically. So we can, for example, dynamically load remote content using the URL function, and we can also calculate things depending on other properties using the calc functions. Then we have selectors, which basically tell us to which element those styles are applied. And we have add rules which act as conditionals. So here we, for example, have a conditional which queries the screen size of the device. So here we have, if the width is greater than 720 pixels, then we apply the style that is inside of that. And if we want to communicate what our CSS is doing to a server, we can do something like this. So we have a button here on the left that is styled with two different selectors, and one of them is inside of a condition. And this condition is basically checking the screen size of the device. And if now a big screen device comes, then we fetch the large image. And otherwise, if the width is smaller than 720 pixels, then we fetch the small image. And by that, the server can basically tell what type of screen your device has and can infer the outcome of this condition. So let's directly get into fingerprinting with add rules. And here, the most interesting fingerprinting technique is based on container queries. So container query looks like this. So we have a width query. And what container queries are actually doing is we can measure the width of a container element. And then depending on the width of that, we can apply some conditional styles. So what this is usually used for is to have buttons or elements that basically style themselves depending on their size. So for example, here, if you have a width greater than 400 pixels, then you make the font size larger, or you, for example, change the background color. So the big question, of course, is how is such a width measurement primitive useful? And with width measurements, you can do a lot of things. And to convince you of that, I have brought 3 examples. So on the one hand, you can, for example, infer the client language. So here we have the file picker element, which has a different width depending on the language of the client. So here, for example, we have English and we have the German version. The German version is just a bit more verbose. Then we can also distinguish browser and operating system combinations, because what the respective browsers do is they try to match the look and feel of the rest of the user interface. So they actually adapt the default styles depending on your platform and also depending on the versions. And lastly, we can also do a lot of interesting font fingerprinting where we can distinguish if a certain font is installed or not. So here at the top, we, for example, have the impact font, and at the bottom, we have the same font size and the same text in a different font, the Montserrat font, and we can see that it has a different width. And based on that, we can distinguish if certain fonts are installed, which allows us to infer what applications are installed on a system, because applications are often shipped with fonts that would otherwise not be available. Then I also briefly mentioned functions. And here we have one interesting function that we looked at in our paper, which is the calc function. And what we do here basically is we calculate the expression pi times pi plus pi. And if we execute that on different architectures, so here if we, for example, execute that on Chrome twice, we execute it once on Intel and once on ARM. And on Intel, we get 13 as a result, and on ARM, we get a different value. So what happens here is we basically have a lot of implementation differences depending once on the browser version, and also the target architecture of the browser, which allows us to infer all of these properties. How do we find such expressions? Well, we basically used fuzzing to find such expressions, and this is just one of the small expressions that fit nicely on the slide. But there are very big expressions that you can use to, for example, distinguish a lot of corner cases. Then there are also plugins, which you can basically install to customize your browsing experience. So most of you will probably have an ad blocker or something installed. There's also the NoScript extension, which I briefly mentioned earlier, and there's also, for example, the Google Translate plugin. And what a lot of these extensions do is they modify the content of a website. So for example, Google Translate operates by basically taking the HTML and doing then a string replace operation onto that HTML, where they basically swap out English characters to your, for example, target translation. So here we, for example, on the one hand have an English website with the term cybersecurity, which has a width of 13 characters. And if we translate that to German using Google Translate, we end up with something that has 15 characters of width. And this is something we can distinguish even with, for example, a monospace font. So not only do we know that translation has happened, but we can also distinguish which target language we ended up seeing, because every language has their unique properties and different things that are translated differently, and we can actually infer this. So to summarize the capabilities of CSS fingerprints, so we can get a lot of system information, like for example, what browser you're using, what operating system, and also their individual respective versions. We can query a lot of hardware information, mostly related to the screen of the device, but also something like the architecture, using expressions like the one I've shown you before. We can query quite some user information, such as, for example, what language settings they have, or also which fonts they have installed, which in turn allows us to infer what applications they have available on the system. And we can also detect quite a variety of plugins that modify the content of a website somehow. So the conclusion and takeaway of this section here is basically all of this works in the browser, and it can also largely replace the capabilities of JavaScript-based fingerprinting. So the big question from the scenarios I've shown you earlier is, what about email clients? So first, we have to understand what an email client actually is. And here we have three different categories of email clients. So we have webmail, which is, for example, something like Gmail. We have desktop clients, which is, for example, Thunderbird, and mobile clients, which, for example, is the default mail application on iOS. And if they render something, what they are actually doing is they use some browser engine. So in the webmail context, you have just the browser that you use to render that site. In desktop clients, what they usually do is they ship with their own rendering engine. So in Thunderbird, for example, they just ship with the Firefox engine. And you have mobile clients, which usually use something like a web view. So you, again, use some browser engine there. So basically, an email client is just a different browser without JavaScript. And inside of such a browser, we can render HTML emails. And an HTML email looks something like this. So we have some tags in there, just regular HTML. And we can also have styles in there. So here we have a style tag that just changes the color of the text to orange. And if we open that using Thunderbird, we get exactly what we would expect. So if we have HTML emails and we can render HTML in the browser, the big question is, can we fingerprint in emails? And for this, we basically only have to check two things. So on the one hand, we have to check if a certain CSS feature is available, because we already know that it is just a browser engine. So the only thing they can do is take the feature away from us. And we have to check if we can have, if we have remote content loading in order to exfiltrate our fingerprints. So to analyze this, we had a big analysis time where we looked at 21 email clients in total. And to each of those, we sent about 100 test emails that we then opened manually to check for the availability of certain features. And doing that, we found that we can basically categorize the behavior of clients into two different categories. So on the one hand, we have very lenient client, which, for example, also includes the Apple mail suite. And what they basically allow you to is they allow you everything you would want to do with CSS. So you can do arbitrary CSS fingerprinting in those clients. On the other hand, we also have more restrictive clients. And this doesn't mean that they are not susceptible to fingerprinting, but it's just that we cannot do arbitrary fingerprinting in there. So they, for example, take certain features like container queries away from us. So the summary here is that we have about half of clients allow all techniques. Almost all clients allow at least some techniques, mostly related to the screen of a device. And sadly, each client supports a vastly different feature set, making this kind of analysis necessary in the first place. So how is email fingerprinting useful? So if you were a good guy, you could build something like this, where you are Bob and you want to send an email to Alice. And if someone else gets that, you want notification. So we embed some fingerprinting code inside of this email, and we can check the fingerprints that come back to us. So if someone else has that email, we see a different fingerprint. Similarly, you can also just use it for tracking purposes, where you get a lot of information about, for example, the operating system. But in my opinion, the most interesting case is the spear phishing case, where you can, for example, target a specific audience that has, for example, some application installed, like PowerPoint. And you can have fingerprinting emails that look different to different people. So to wrap things up, what we learned today is that style sheets alone can be used for very advanced fingerprinting. And with that fingerprinting, we can also use it inside of emails, because the requirements have been reduced so much that it can also work inside of them. And with that, I thank you for your attention.
Thank you very much. Very interesting work. We have time for a couple of questions. I actually have a question to start with until we get somebody in the line. It's actually just a request for clarification. It doesn't look to me from thinking about the threat model here that the attacker needs to be very powerful. Like that, you're not assuming the attacker has a lot of privilege on the system, right? Like, so what does the attacker, what privileges would the attacker need in order to do that?
So here we basically just assume that the attacker can send an email to a victim, for example. So we do not have to have control, for example, over the mail servers or anything, because a lot of mail servers actually just forward what you send them, and a lot of mail servers are not that restrictive with the HTML that they allow.
Oh, okay. And so basically, anybody who can run something on your browser.
Yes,
on your,
so you could, for example, from Gmail, send a fingerprinting email to some Apple client.
All right, thank you. Okay. Please.
Hi, Cameron Morris. Thank you for the talk. I know this talk is about CSS-based fingerprinting. I saw Microsoft Outlook, the desktop client, in the restrictive email clients category. As I understand it, Outlook actually uses Microsoft Word as a rendering engine, not a browser. Did you consider or look into any Microsoft Word-based fingerprinting techniques instead of CSS?
That is an interesting question. So no, we just checked for feature availability in those clients. And also, sadly, there was a change in Office since the basically testing of the paper, because there's now, I think it's an Electron-based Office version that is now, again, completely different from what we looked at in the paper. So the Office versions change quite frequently.
Okay, thank you.
Thank you.
Let's thank the speaker one more time. Thank you so much. Oh, sorry, I didn't see it. We could go ahead. Sorry, I didn't see you. Go ahead. Go ahead.
Okay.
Yeah.
So, hi. I really liked your presentation. Thank you. Quick question. With the desktop and mobile native email clients, usually a lot of them have the option not to load images from remote servers. Does this feature actually also disables the CSS background image loading and thereby eliminating this attack, or does it not apply to CSS?
So what we actually noticed in a lot of cases is that these proxies, which are basically acting in the background, are still acting conditional on what you open in your email. So what they basically just do is they replace all of the remote URLs with proxy URLs, which are then still fetched based on the condition that your CSS had. So you can still get the output of those CSS features, basically. The only thing that they do is basically they obfuscate your IP address and your user agent header and so on. But you can still get a lot of the fingerprinting information still with proxies enabled.
Thank you.
Thanks.